Introducing NeuroFeel, an AI-powered emotion detection model built on a lightweight version of NeuroBERT. NeuroFeel is designed to accurately detect over 10+ different emotions from text, including happiness, sadness, anger, love, and more, all in real time. You can train it with your own data, customize the emotion labels, and even deploy it in real-world apps. And best of all, it's completely open source and free for personal and commercial use. Start building emotion-aware AI today with NeuroFeel. Step 1. Collect the data. We start by loading a balanced dataset from a CSV file. Each entry contains a short text and its corresponding emotion label. The dataset is then split, 80% for training and 20% for validation. Emotions are encoded as numbers, for example, sadness as 0 and happiness as 5, so the model can learn to predict them effectively. Finally, we clean and pre-process the text to make it suitable for training with NeuroBERT. This step builds the foundation for everything that follows. Step 2. Initialize NeuroBERT. We load NeuroBERT, a lightweight powerhouse model, just around 50 megabytes in size, and licensed under MIT, so it's free for both personal and commercial use. We start by using the BERT tokenizer to convert our text into tokens that the model can understand. Then, we load the pre-trained NeuroBERT weights and configure the model to classify over 10 different emotions. We set the maximum input length to 128 tokens, perfect for short messages, social posts, and chat inputs. Now the core model is ready for training. Step 3. Build the data pipeline. We define a custom sentiment dataset class to prepare our data for training. Each text input is tokenized with padding and truncation, ensuring a consistent format and length. The output includes input IDs, attention masks, and emotion labels, exactly what the model needs. Finally, this dataset is fully integrated with the Hugging Face Trainer API, so training becomes simple and efficient. With our data now structured and ready, we're all set to start fine-tuning. Step 4. Train the model. We fine-tune NeuroFeel over 5 epochs with a batch size of 16. To ensure stable learning, we apply warm-up steps and weight decay, helping the model converge smoothly. After each epoch, the model is evaluated on the validation set so we can monitor performance in real time. We also log the training loss, giving us insight into how well the model is learning. By the end of this step, NeuroFeel becomes truly emotion-aware. Step 5. Test and save. We validate NeuroFeel on the held-out data, reaching around 95% accuracy. The loss steadily drops from 0.54 to 0.35, showing strong and stable learning. Once training is complete, we save the model and tokenizer under the name NeuroFeel. Now the model is fully trained and ready to make real-time emotion predictions, anytime, anywhere. Step 6. Predict emotions. NeuroFeel in action. Now that the model is trained, it's ready to predict emotions from text in real time. For example, the input "I'm thrilled" is instantly classified as happiness. NeuroFeel delivers precise emotion labels, even for short or casual sentences. Just load the saved model, and it's ready to go. Whether it's for social media monitoring, mental health support, or intelligent chatbots, NeuroFeel brings emotional awareness to your applications. Step 7. Build your own classifier. Using our ready-to-use neuro_feel_v1.ipimp notebook and Hugging Face tools, you can fine-tune NeuroBERT with your own data. Join the exciting revolution where AI meets emotion, creating smarter, more empathetic applications. Thank you for exploring NeuroFeel with us. With around 95% accuracy on 10+ emotions, NeuroFeel masters diverse texts and empowers AI to truly understand human feelings. This is how we're revolutionizing AI empathy, one emotion at a time. I'll walk you through training the NeuroFeel emotion detection model step by step. Step 1. Data prep. Load the dataset from a CSV and drop rows with missing labels. Rename the columns to text and label for consistency. Step 2. Label encoding. Map emotion labels to numeric IDs, e.g., happiness 0, sadness 1. This numeric form is crucial for model training. Step 3. Data split. Split data into 80% training and 20% validation to evaluate generalization during training. Step 4. Tokenization. Use the NeuroBERT tokenizer to convert text to token IDs. It handles truncation and padding, max length, 128. Step 5. Custom Dataset Class. Define a PyTorch dataset class to return input IDs, attention masks, and labels as tensors. Step 6. Dataset Loading. Instantiate training and validation datasets using the tokenized texts. Step 7. Model Initialization. Load the NeuroBERT model for sequence classification and set the number of output emotion classes. Step 8. Training Config. Set up training. 5 epochs, batch size 16, warm-up steps, weight decay, and evaluation after each epoch. Step 9. Trainer Setup. Use Hugging Face's Trainer API. Provide model, datasets, training arguments, and callbacks for progress tracking. Step 10. Train and evaluate. Train the model and monitor its performance on the validation set after each epoch. Step 11. Save model. After training, save the model, tokenizer, and label mappings locally for future use. Step 12. Zip and share. Compress the model folder into a .zip file for deployment or sharing. That's it. You now have a fine-tuned NeuroFeel model ready to predict emotions in real time. Thanks for watching and happy coding.